Okay, good morning, everybody. I will talk about how we can possibly use windmill towers as cellular towers. We have studied this problem since the beginning of the project. In the first year, we did the initial studies, and then it was halted, and now we have continued working on this problem. And in general, if you look at the literature and internet, you can see that there are some studies, but not giving all the answers what you need, and that's why we are still continuing this process. So, for example, military guys in Finland, Sweden, and elsewhere, they are saying that these windmill towers are disturbing their radars, and radars are RF things. So in the civilian cellular connectivity, we would expect similar kind of behavior for our signals, but there is no data available how bad is this disturbance. Is it really matter in wireless communication? So that is open question. I have seen some studies, but they are so theoretical that you cannot understand what is the attenuation of these blades. Or they have not concentrated on those, but other aspects on the propagation. We already know that some windmill farms are using these 4G networks or maybe now 5G networks, but they are in the sea. The reason is that in the sea level, there is this figure, you can see this base. So in the sea, these towers are put above the base, and they can put these cellular antennas on the top of this base. So there is platform, these cellular devices below the blades, but still well above the sea level. So it's not problem there. But at the land, if you look at this land windmills, there is not this kind of base. So the problem is where you can put these antennas. So then this slide is about what are the potential benefits, why we should do this kind of things. So we have discussed with the windmill farm owners or operators, and they said because these windmill farms are often in remote areas and people have to go there for work and other things, and if they don't have connectivity, and it's wireless connectivity, when they are moving there, they have problems, and it is inefficient because they have to drive to places where they have connectivity, then drive back to place where they are doing things, and so on. They also need local connectivity around these windmill farms. So it's needed for the people who are doing business there. Then it would be nice to connect these towers to collect data, doing joint control and so on. Then then they have, I think mostly they have fiber coming there, but if that fiber breaks, then there's no connectivity at all. So this wireless connectivity could be a backup solution, while it provides this local connectivity for moving people. Then if people would know that they are using these windmill towers as cellular towers in remote areas, maybe they would be more acceptable towards these towers. And then I'm not sure what is how big volume is this business case, but there is at least minor possibility for doing business. Those were the benefits for windmill operators. Then for mobile operators, if they could use these towers, is that there's reduced cost, no need to build these towers, just put the antennas there and operate. It's quick, there is roads ready, there is electricity ready. There is, I think most cases there is this fiber ready. So just put the cell there and it's working. And often these are in high places, and it means better coverage in remote areas. That is always bonus. And then for us ordinary people, what are the benefits? Of course, it's better coverage and connectivity in remote and rural areas. Like if you are doing hiking, fishing, or something else in the wilderness, it's good also for these reindeer herders, because they are now building these windmill towers to the reindeer herding areas, and those could provide this coverage too. And of course, this emergency services 112 calls can be made in larger areas if you have connectivity. Then where you can put these antennas, what we studied also earlier. One place is this below these blades or wings of the wind turbine. Then you don't have this disturbance. Yeah. So in this area, so then you don't have interference from these blades, and still it's rather high. If you look at these towers, it's 30 meters or maybe even more from the ground. So it's usual cellular base station on top of hill. You have that kind of situation there. So quite good position there. But the problem is how to attach these antennas. I think they do not want to put holes in these structures. They should use something else. Then higher in the tower, so it's this area. The situation is similar. You go higher, you have a bit better coverage, but then you have these blades between you. Possibly these blades are between you and the antenna or base station, or you can go to the top. So it's usually over 100 meters. I think highest are 200 meters, so potentially very good coverage. But then there are these blades are causing you problems, and also this nacelle, this big structure here, size of the bus, is there, and it can also limit your coverage, especially on those directions where that is. And then this nacelle is turning when the wind changes, and that means that you have to have beam handovers, but they are already in the standards, or you have to have rotating antenna if you do not want these moving cells. But that might cause interference. You have to do also this frequency control with the neighboring cells. Challenges, what we have seen, and we don't have answers to all of these. Maybe there could even be further project on these, like this maintenance of windmills or base stations. When you go there, what you have to do? So you have to have first this, if it's very high there, you have to have these climbing and access permissions. And who gives you? Is it the operator of the windmill or operator of the cellular tower? How they agree that? Then do they have to shut down the cellular base station when they do maintenance of windmill? There is microwave radiation and high power. Probably you have to shut it down. So it means no 24/7 operation. That might be critical for some applications. But they have to shut down even regular base stations. So maybe that is not the problem, but the question is how often this is done. How often you have to shut it down. Then this business thinking, it needs more studies, especially if you make it commercial. Of course, it's only for local use of windmill operators. Then it's quite easy. They just calculate should we invest for this or not. But if it's for commercial use, then there is need for calculation. Then who is operator? Is it cellular operator, windmill operator, or some local operator? And then there are always these questions of frequency licenses, and roaming is big problem. Then if you are small operator in the area. Then what we aim to study is this propagation through blades and nacelle. Is one problem. We have not yet found solutions from the literature for that. And then antenna impact on windmill operation. So if we put this 1 meter high antennas on top of nacelle, does it affect to the operation of the windmill? So for the propagation, we have discussed with the windmill operator and think how we can do these measurements easily. We don't have climbing permissions to the tower, so we have to do it from ground. So one possibility is in this picture. So we will have flying drone with the receiver, where we can measure different things of the signal, and then we have vehicle where we have transmitter. Of course, we have to take care of this geometry so that there is plate between the radios. And it's easy to measure the attenuation. It's constant every now and then. It happens there. If you go closer to nacelle, they are more frequent because it rotates more. Speed is different at the ends of the blades than in the center of the nacelle. But that is then impacting if there's big attenuation due to blades, then the impact is higher if you are in the center of nacelle than at the edge of the blades, because there are more these turbines. We have to analyze also this effect later on. So this measuring of this blade effects is basically what we can do very easily with our existing equipment. But then the more tricky thing is then that if we put the antenna on top of this nacelle and how we can measure it. Basically, you need 100-meter RF cable, and the losses are too high for us. It's not possible, but maybe if the windmill operator persons can put the antenna there for testing the antenna impact on the windmill operation. That is the purpose that we will not rent, but give all antennas to them so that they can install them and put them there. But still we have problems. They have to put the cable inside the nacelle, then they have to learn how to use transmitting radio systems. Probably it must be some kind of signal generator, and put it there, put it on. Then we can do the propagation measurements around the area and see how it works. And then they have to go there and shut it down, bring it back, and so. So there are a lot of things to solve before we can do it. And also where we direct this antenna. Probably we are not targeting these 3 or 4-dimensional antenna system, only looking to one direction. And we want to, because if you propagate away from the blades, there's nothing new. We know already how the signal propagates. We want to direct the antenna so that blades are between you and the antenna, the transmitter, so that we can see the impact of blades and nacelle to this propagation. And we plan to do this in the summer or most probably in late August, early September. I think we have to still plan the measurements later on. And we have to also ask the frequency permission and flying permission, but these flying permissions are okay. So we only need these frequency permissions. So. And then final slide is where we are planning to do this is in close to Piteå. There are a lot of windmills, as you can see in this figure. And I think this is only small part of this Piteå windmill area. Okay, thank you. Sweden, yes. Thank you. Any questions?
Harri, thank you. So yeah, open for questions.
Yes, I have one question about this. So means you are talking about the installation of the antenna about in the wind tower. So instead of this, like this is the plate, so we can put behind of this the plate, so the blades will not interrupt the antenna. Like if it is the tower, then blade is this side, so we can put like this here, the back side.
Yeah, but that we know how the signal propagates if there is no blade, because you just use the regular propagation models to predict how it goes. Yeah.
Yes, and another is like when we talk about this wind farm, then we have lot of winds up. So we can use this distributed antenna based system. Instead of putting one heavy, we can put small, so it will not weight it to one windmill. Like in the Piteå, we have lot of windmills.
Yeah.
So we can use this distributed base station phenomena.
Yeah, basically, yeah, but then it's more installations and.
Yeah, but it's increase and it will not burden to one windmill.
Yeah, but even if you put the small antenna, you have to go up, put the radio. Or nowadays, I think there is this AESA, not RIS, but this AESA, this where you have RF parts and antennas together. You just put them up, and it's optical cable down to your base station. But still, you have to install.
Okay. Yeah.
For every site, you have to install this anyway.
Yeah.
Is it? I think it's big or small base station. You have to do the same installation.
Yeah. Installation is a problem, but yeah.
No, it is one of the features of these parks is that you have many towers relatively close to each other.
Yeah.
So you could it would be an interesting idea to somehow say, can we exploit that? You don't have that anywhere else, right? That you have several high towers in a vicinity.
Yeah.
But yeah, there is the installation cost. That's true.
But the other thing is that the blades are all in the same direction. So if you're directing antennas to the other direction, you'll miss one direction.
Right.
Yeah.
Right. Yeah. I guess there's a lot of good technical questions to research questions to be addressed here. I have one more question on the business case though. So if you have, the market has not, let's say, found this solution, right? I'm not aware of many operators that have base stations in these towers. Yeah. So what is the main reason, do you think, that the market has not already somehow found this? Why is it not already happening?
I don't know. Basically, you don't need not so many base stations in remote areas. You need some. So
yeah,
I guess that in one windmill park, you need only one for the coverage of the whole park,
right?
And a lot of surrounding area.
Yeah, volumes. There won't be a big volume market for this, right?
If the operators are not now willing to invest their own base stations, own towers into remote areas, maybe they don't want to use these windmill towers.
Yes. Now you mentioned also on your slides, there's quite some work to do probably on the business case side,
Yeah.
on the acceptance of this.
And we have not even seen this feasibility of this thing, so that if this
Sure.
blade problem is too severe, then it does not make much sense. Yeah. At least put them in the top.
Yeah. Good. Thank you, Harri, for this. So